Common data concepts. This chapter is about getting familiar with those terms that come up frequently in business intelligence with regards to data. I want you to understand data types and data storage basics. You'll learn how BI analysts join data from different tables efficiently. We'll explore the basics of metrics and functions and how they can be used to manipulate values. Finally, we'll go through exactly what a data model is. With this knowledge, you should feel comfortable holding conversations about concepts in business intelligence, and you'll be ready to start your journey of mastering these business intelligence tools. We've all had that moment when a VLOOKUP doesn't work in Excel because you're dealing with numbers instead of text. And that's because text is a different data type to a number. But those aren't the only two data types. We also have decimals, integers, percentages, dates, times, datetimes, text, locations, and true or false values, which are known as Booleans. And just like in Excel, in most BI packages, we need to define what the data type is that we're working with. And there's two key reasons for doing that. First, defining data types helps optimize the amount of memory used to store our data. Some of these data types take more storage than others. The second reason is that data types also help our software understand how it can manipulate our values. So how exactly do we manipulate data values? We do that using functions. Functions are like formulas. They allow us to perform a calculation or manipulate an input value. Take the round function in Excel. We want to round a given number to 2 decimal places. Each of the values we use as an input to the function is called an argument. So here we have number and decimal places. And once we've passed those numbers to the function, it returns an answer. And some functions even have an unlimited number of arguments, such as the sum function. And more generally, there are many different functions, which usually allow you to manipulate a particular type of variable. So that's why it was so important that we defined what type of data we were working with. Now it's fairly obvious what types of data number functions, text functions, and date functions can manipulate. But what about Boolean functions? Let's take a closer look at that data type. Boolean values describe whether a condition is true or false. And comparison operators can help us define Boolean values. The most common comparison operators are equals, greater than, less than, or not equal to. We can use those in an expression to determine if a condition is true or false. For example, are total sales greater than 200,000, or is this credit score lower than 600? In both cases, we get a true or false value known as a Boolean. So we've talked about data types, values, and how you might manipulate them with functions. But where are those data values stored? We have several different data structures that help us store data. The first is simply a variable, which stores a single value. For example, in your Excel model, you might have a named range called interest rate with a value of 3.2%. You'll also be familiar with a table, which can contain multiple values. Tables are arranged in rows and columns. Usually the columns of a table are related to each other. For example, we might have an order ID and an order amount. Next we have a list. And in simple terms, you can think of this as a single column table. But in the case of a list, we don't need any other columns to explain it. For example, a list of dates. We also have arrays, key value pairs, and hash tables, but you'll find out more about those in our BI courses. We often have a choice about which of these data structures we use, but what's true of all of them is that data structures help store one or more values in an appropriate way for our analysis. In this intro to BI, we've talked a lot about combining data from different sources, which often involves combining data from 2 different tables. This is a really important concept in BI, and I want to take a moment to explore the 3 different methods we have to combine data from different tables. The first method is appending tables. Appending tables allows us to combine rows from different tables into one giant table. Appending tables is also known as a union. And for this to work, generally the input tables must have the same column names and the same data types. The second method we have is to join tables. Joins allow us to physically combine 2 different tables into one by matching column values. In this example, we have a list of transactions, which each have a customer ID. We have a separate table that contains customer IDs and names, and we simply want to return a customer name each time we find a matching ID. Creating this link gives us one physically combined table. The columns that we use to join tables are known as keys. And in our example, the customer ID column in the transaction table is known as a foreign key because it's used to identify a row in another table. Conversely, the customer ID column in the customer table is called a primary key, and that's because it identifies a row in this table. The final method we have to link tables is known as relationships. Relationships create a connection between 2 tables, but keep them physically separate. In that same example with a transaction table and a customer table, we simply create a relationship between our foreign key and our primary key columns. The advantage of relationships is that the values in the other table are only accessed when they're needed. For example, if we were to ask the question, what is the total revenue for Preeta Maya, only then is that customer table used. We might use it in a formula with a filter condition to say we want the customer name to only equal Preeta Maya. So in summary, columns are only used when they are needed. Also, relationships help reduce storage space. In the above example, Preeta Maya appears twice in the transaction table. So instead of storing her name twice in that table, we only store it once in the reference table. Each method of combining data that we've looked at serves a different purpose, and you'll learn more about them as you progress through our business intelligence courses. We've seen that our data values can be stored in different data structures, but where do we actually save those data structures so that we can access them later on? We save them in files or databases. And here are the most common file types. We have the Excel file, which stores values, formulas, and formatting, which is good for analysis, but bad for storage, as all that extra information takes up space. CSV, or comma-separated value files, store values in an efficient text format, where each value is separated by a comma. We have JSON files, which offer a flexible and efficient file format, which is usually used to move data between systems. Finally, as we said before, we can also store data in databases, which offer robust, centralized data storage, which is often considered to be the one version of the truth. As you can see, all of these storage types have their advantages, and so it will always depend on the scenario as to which one we choose. A term you'll hear a lot in business intelligence is the data model. 2 or more tables connected with relationships are referred to as a data model. And in simple terms, we have 2 types of table in a data model. We have a fact table, which records events like sales, transactions, loans, or website hits. This is usually where you'll find your measurements like revenue. The foreign keys in the fact table give us clues as to who, what, where, when, or why the event occurred. Here we have a date foreign key and a customer ID foreign key. To get the details about those keys, we have to look in what's called dimension tables. Dimension tables contain the data that helps us describe those IDs in more detail. So in summary, fact tables contain measurements about events or transactions. Dimension tables contain attributes that help describe the events in more detail. In the previous slide, you may have noticed that we use lines between the tables to denote relationships. In this case, we used multiple lines at one end and a single line at the other. This was deliberate and denotes a particular type of relationship called a many-to-one. This means that each key can only appear once in one table, but may appear many times in the other. We would only expect Preeta Maya to appear once in the lookup table of customers, but she may appear many times in the transaction table. A one-to-many relationship is the same as the above, just expressed the other way round. Then we have a one-to-one relationship, which means we only have a single occurrence of the key in each table. Finally, we have a many-to-many relationship, which means we potentially have many occurrences of each key in each table. Generally, we try to avoid the many-to-many relationship as it can cause a lot of complications. In general, relationship types help us to understand and manage the duplicate values that appear in our data.